Hi, I'm Dave here. So let's take a look at this Racal Dana multimeter. It's the model 5900, and it's a beautiful 5.5 digit multimeter that I got for very cheap on eBay. It actually worked for a while, but now it's turning to, it's misbehaving a little bit, and there is one little glitch sometimes. There is a relay that goes a little bit crazy and doesn't really work properly, and so I'm gonna actually clean also the switches because they're a little bit crusty as well. So yeah, it's a good opportunity to look inside, take a look inside and see how it works and what's the problem with it. So let's open it and see what's inside. Alright, that should come off. Oh! Alright, so here we go. Let's start by looking at the power supply section. Obviously, there is a big transformer here, and look at how many taps they have here. And I wonder if this fails, what you're gonna do, man. I think you're pretty much screwed. But anyway, huge capacitor. Anyway, this is the optional board for the program. It's a J202 program board. I don't have the programmer because this thing has a dedicated unit that controls the other. So via GPIB you can actually control this thing. I don't want to use it and I don't really care. So yeah, but it has the board. Bunch of logic on the bottom, and we have another shield here, and we have a board underneath with some connectors. So I wonder if this is a mod or an option. I do not know. It seems like an optional board because we have two big connectors on the back. But it's a little bit suspicious because, yeah, it's kind of flopping around, and the screws are already a little bit, someone was taking the cover off without paying too much care about the screws, maybe utilizing a wrong screwdriver, and it left the board like this. It's just no good. I wonder if this is the problem. Obviously, all the exciting parts are under this shield, so let's take this off and see underneath. And I love when they actually tell you all the calibration steps on the shield, which is very nice. I have another multimeter, that bench multimeter, that has the same thing. I have it right there. Look at that, all the calibration sequence right on the shield, which is just nice. You don't have to, get a service manual or something. I think this thing comes off. Nice aluminium kind of thing, and wow. Oh, this is crazy. How many? 1, 2, 3, 4, 5, 6. It's a dream. Oh, look at all those coils here. Just very nice. Perhaps I'm pretty sure that the relay is worth more than I paid for the whole unit. But anyway, I see 1, 2, 3, 4 boards. It can be disconnected. Oh no, there is a 5th one here. And I have to be quite careful with it because it has 38 years, almost 4 years, and yeah, I have to be a little bit careful. Alright, so we have all the boards on the bench, except the last one, which is the switching board. Unfortunately, I couldn't really get this other one out because it has a pretty big connector on the back. So yes, and this was a little bit stuck. But there is nothing really too much exciting about it. There are some relays and some diodes. But anyway, on those boards, on the bench, we have from right to left, we have the AC converter. So this is the AC Scaling Amplifier. Basically, it's the true RMS AC converter. Here we have the digitizer board, and this cares about the analog to digital conversion. This is the isolator board. This is the attenuation board. You can actually judge by those those three relays here and those precision resistors. We'll take a look later. And this is the little board that's actually quite cute. This is the 4-wire ratio board. And on the main board we are left with those beautiful connectors. Those are gold-plated pins. And here we have Mecca, which is a rather quite interesting Stargrand point. In fact, it is actually the guard ground here. Alright, so let's start by the AC scaling amplifier here, and as the name suggests, it actually amplifies the AC signal to a suitable level for the converter. It also provides some isolation from the input to the converter itself. And it actually basically works by a AC coupled operational amplifier with 4 different gain settings, and those gain settings are controlled by those 3 relays. There is one underneath the shield. There's the true RMS converter under the shield, but there's nothing too special. So if we take a look at the actual schematic here, this is just a simplified version. You can actually see this is the AC coupled operational amplifier, and we have the 4 gain settings 1, 2, 3, and 4 right here, controlled by those 3 relays. Alright, so unfortunately I have to reshoot this part here because the sound of the original was completely ruined. I don't know how, but anyway, whatever. So I have the schematic of the true RMS converter. This is the simplified version anyway. So let's start by here. Your AC is fed through here. It gets AC coupled, and this provides some isolation as well. So it gets to the scaling amplifier, which I said before, with the 3 relays and the 4 feedback path. The output of the scaling amplifier is fed through 2 path right there. So the first one is the full wave signal, which is fed through this 20 kilo ohm resistor to this node. So the other path goes to this very interesting little device, which is an active rectifier. Basically, it's just a operational amplifier with 2 polaritive selective feedback path. So those 2 diodes right there. So this means that one is only conducting with the output of the scaling amplifier is positive, and the other is conducting with the output negative. So let's say it's positive, so it goes through here, and the positive only part of the wave is fed through this path right there, through this 10 kilo ohm resistor. And you can actually say here, this is the point A, and it's the actual full wave signal out of the scaling amplifier, and you have
this point here. The point B, which I said, let's say it's the positive output here, is only the positive part of full wave signal. On this node here, the two signals are combined and they are fed through the summing node of the logarithmic amplifier, which is this device here. Due to the nonlinear behavior of the logarithmic amplifier, the output of the logarithmic amplifier will be the log of the two combined signal, which is this waveform here. Then this actually goes to an identical path and gets all over again, and then gets to the final summing amplifier, which actually converts the AC signal to a equivalent DC level. So the ripple is reduced, and you get the DC equivalent of the true RMS measurement of the AC input.
So this is the digitizer board, and here is where the analog to digital conversion is performed. So it consists of various blocks. So you can actually see here, this is a block here, this is another block, and other, and so on. So your DC input, basically, because everything here, the AC converter board and the reference, everything is converted to an equivalent DC signal, alright? So your DC signal is fed through this integrator, and basically what it does is, by this operational amplifier and a capacitive feedback path, it converts your DC signal to a corresponding ramp, alright? This ramp is then amplified through this gain stage, and it's just a amplifier. This is then, your amplified signal is then fed through this null detector, and basically the null detector is the equivalent of the modern, let's say, analog to digital converter, which is then fed through this transformer driver and through this isolation transformer. As you can see on the same board, we have some switching controls and the two references supplies, so the plus and minus references, which I think are in this board right there. You can actually see on the board itself the three transformers here. I think this is the integrator circuitry, and I think this is the actual supply, the reference supply. I'm not entirely sure. And here all the switching logic. Alright, so this is the isolation board, and we'll actually pop the cover off and see what's inside. Alright, so this board consists of various parts, and the first part is the high open loop gain amplifier and a bootstrap amplifier right there. And actually this is also the filter where the filtering is engaged on the front panel. There is a filter switch, engages a filter that increases the normal mode noise rejection from 10 to 48 decibels. So this is the actual relay that it activates the actual filtering section. Once again, schematic here is very handy. So we have the attenuator section right there, and we have the first gain stage amplifier. This is the open loop gain amplifier, and we have the bootstrap amplifier, which is very interesting because it actually generates the plus and minus voltages for the input stages. And this actually, it calls them to track the input signal right there. So what this means is that it calls the input impedance to be greater than 10 megaohms. So basically it's an infinite input impedance which is done by this bootstrap amplifier right there. We then have the filtering section here, which is a Bessel type filtering, and then we have another amplifier right there, and all here goes to the analog to digital converter, basically the digitizer board. We then obviously have the switching board, which is actually just a relay controlled voltage divider, which actually provides the selectable gain. You can actually see here those resistors, and those are very special ones. Those are Kelvin made resistors, and if you see here, there's a 0.025%. So yeah, and those are 2.2499 meg resistors. We have another one here, 899.45 kilo ohms, and we have another one here, and we have those V-shape precision resistors, 0.01%. And this is the block diagram and the signal flow of the switching board, if you take a look. And yeah, I mean, it's just very simple kind of stuff. And last but not least, 4-wire ratio board, which is just a consists of two isolation amplifier driving a differential potentiometric amplifier. And this is the schematic for the 4-wire option board. Alright, so sorry for the handheld, but I popped the cover off here, and it revealed a very fascinating thing. This is, by the looks of it, an original mod that has been done back in, I don't know, maybe 70s or 80s, perhaps, by the looks of all the old components. So it means that this instrument here has been modded, perhaps in France, because I see those connectors here, and those are French connectors, Interelco de France. So also the coaxial wires are from France. Don't really know what's going on here, and they are tapping the voltages all over the place. Look at those mods wire. They are tapping the voltage from here right there to the lead of the capacitor. That's a little bit, you know, here as well. I mean, and even from the transformer as well. Look at that. And those coaxial wires are attached to those banana plugs that on the back it's written the external is for the external reference. So on the board we have some chips here, we have some quad NAND gates, we have an optocoupler, perhaps it's a operational amplifier, I don't know. This is a rail-to-rail, very schmick rail-to-rail operational amplifier right there. Some transistor perhaps for driving the relay, and some operational amplifiers right there. And look at the stuff here. I mean, has been modded. And by the way, this mod doesn't work because funny enough, this actual relay is flapping around here, and it's completely detached from the board. So even the wire that energized the relay is detached, so it doesn't really work right now. And they actually modded the thing. They drill a hole on the front and they added a little switch, and I thought that was actually original by the writings here, but apparently it's not. Alright, so I've removed the board, and as you can see on the bottom, it seems like it has been custom etched by someone, and then hand soldered together. I mean, that's fascinating, and they're gone on the effort to put all those shields and even mark the resistors you know, see here, R7 and R9. You know, I'm really tempted to resolder those wires here. I mean, judging by the location, it was there, and this was right here. Alright, so I tested the thing with and without the board, but man, does absolutely nothing. I mean, even the relay doesn't start, so yeah, I'm just thinking about the possibility to remove all this wire harness right there. I mean, the mod. Alright, so after a little bit of research, I just think I found out what this mod was for. So I think it was actually modified, the unit was modified for different type of ratio measurements, and it's right there on the manual. So it says ratio measurements are made by applying a positive DC voltage to the reference input terminals on the real panel. So my model here is actually equipped with the option, what is this, option 62, I think. Yeah, option 62 actually allows you to have a 4-wire ratio measurement, which is very cool because you can actually have, you know, it says right there, for DC, DC or AC DC ratios, the reference voltage must be within range of +1 or whatever. The readout is the ratio multiplied by 10. Input over the reference times 10. So in the standard instrument, the minus input terminal is internally connected to the minus reference input terminal, but in my example here, I have the option 62, so both reference inputs are floating. Alright? This, what actually is interesting is that someone modified this thing to not have the multiplication by 10, but also by 33 and a half. So you can actually see here where the actual switch was. You could switch from the 10 multiply, at least it's what I think it is. You could have the multiplication by 10 or the 33 and a half. Your 4-wire ratio was input over reference times 10 or 33.5. So it's kind of a, I don't know why you need to have that, but you know, in some industrial application perhaps they needed to have the 4-wire ratio measurement multiplied by 33 and a half. So I think that was the actual what this was for. So man, they actually went on all the trouble to build this whole circuitry to multiply your signal to a different value. So that is actually interesting. This is the actual formula used for the 4-wire ratio. There we go. So this was multiplied by 10, but you could actually switch from 10 to 33 and a half. Alright, so I think that's it for this video. So, hope you enjoyed this look at the Racal Dana 5900 digital multimeter. It's a very nice instrument. So, yeah, hope you enjoyed. And as always, thanks for watching, and I'll see you next time. Bye!